Hey everyone, Johnny here and welcome to another video. Today we're going to be looking at how to solve a quadratic equation, and I'm going to be showing you what that means in the context of a quadratic function here with a graph. Before I do that though, could you please do me a favor and subscribe to the channel and hit the bell so you're notified of all of our new content, and if you do enjoy the video, please make sure you like and comment. Okay, so how do you solve a quadratic equation? Well, there's a few things to address first of all. We need to establish what a quadratic even is. So I've done an example here of a quadratic, y equals x squared minus 6x. And the reason this is a quadratic function in this case, because we've got the y equals x squared minus 6x, right? If we didn't have the y and we just put 0 straight away, we could just call it a quadratic equation. But the reason it's a quadratic is because the highest power of x is 2. So we have x squared minus 6x. If we had x cubed in here, it would no longer be a quadratic. It would be called something else. For example, a cubic. If you had x to the power of 4, 5, 6, it also wouldn't be a quadratic. So you need to make sure that you've got an x squared term in the expression here for it to be a quadratic, and you've also got to make sure that there are no other x terms that have a power greater than 2. So we only want x squared and an x term, or you could just have a number here, or you could have the x term here and a number. But we don't want to see a power other than 2, or certainly one that is greater than 2, next to this x squared term. Okay, so now we know it's a quadratic because of this x squared term being the highest power x term. We can now establish how you'd actually solve it and what that would even mean. Why would you even need to solve quadratic equations? So even though you won't always get a question that starts with y equals then the quadratic expression, I want to show you this example because it puts things into context. It makes it easy to understand. So imagine that you had this curve y equals x squared minus 6x, right? Because it's a quadratic, it's going to be represented by the shape of a parabola, which is either this U shape or upside down U shape, okay? And you can see an example over here where I've graphed roughly y equals x squared minus 6x. Now, you can look more into our videos on what a quadratic actually is and why it looks like a parabola to understand that a bit better, but just accept that if you are dealing with a quadratic function or a quadratic equation, if you were to graph it, it would have this U shape. It might be a really wide U shape, it might be upside down, and it might be really narrow like that. Okay, so it's always got that U shape, whether it's the normal way up or it's upside down. Just like if you had a linear equation, it would just be a straight line, right? If we were graphing a linear equation, which would be something like y equals 2x or y equals a half x, something without the x squared, but definitely something that has just the x in it, and it can have a number before it, that would be represented by a straight line on this graph. But here, because we have a quadratic, it changes the nature of the function, and if we were to plot every single possible point, and we would get all the combinations, it would reveal this U-shaped curve. Okay, so when we want to solve it, when we want to make the y 0, what we're really doing here is we are asking ourselves on this graph, where does this function go through the x-axis? In other words, where are the x-intercepts? We are interested in where the x-intercepts are. That is, where does the function, where does x squared minus 6x, if we were to graph it, go through this horizontal axis, this x-axis? Okay, and the reason we're finding that by substituting y for 0 is because when you want to find an x-intercept on a graph, you can only do so by making the y-coordinate 0. Because think about it, where are your x-intercepts always going to happen? If you're finding a point that lies on the x-axis, the y-coordinate that matches up with those points must be 0. Because think about it like this, here's the y-axis. If we were to get a value up here, it would be something like 10. Then we would go down to 9, 8, 7, 6, 5, 4, 3, 2, 1. Then we'd get to 0 by the time we arrived at the x-axis. And that's the point. That's the line we're interested in if we're going to find where this line cuts through the x-axis. So for both of these points here, which are called the x-intercepts, I already know that the y value is 0, and you always do the y value second in the brackets on the right side. And what we're interested in is finding what the x value is. What is the x value at these 2 points where y equals 0? Okay, so that's a precondition. Y must equal 0. So often you'll get a question that simply says, solve the equation 0 equals x squared minus 6x. So it would never have even said y. It wouldn't have even given you a graph. But I like to visualize a graph and pretend that initially there was a y there, and we have substituted it for 0 in order to find the x-intercepts. So I find that is a better way of understanding what you're actually doing. So the question is, if we've subbed in 0 to find the x-intercepts here, how do we actually find what values of x will make this side equal this side? So remember the point of solving an equation. What does it mean to solve an equation? It means to make both sides equal. We want to make the left side equal the right-hand side. The left-hand side equal the right-hand side. And what that means here is we need to find a value of x. So what x values, what number could we substitute in for x, right? What x values would make the right-hand side equal the left-hand side? And in this case, the left-hand side is 0. So what values of x could I substitute in here so that all of this would equal 0? So we want to make this right-hand side equal 0. We, of course, could rearrange this and make that the left-hand side, and 0 could be the right-hand side. That doesn't really matter. Okay, so we will start by leaving 0 here, though, in this case. And then what we're going to do is, if we want to solve this, so I'll just rewrite it. If we want to solve this now, the question is, how do we do that? It's not so easy when you've got two x's here that aren't like terms. See, we've got x squared and 6x. So there's nothing that's immediately obvious for us to do to solve what value of x. We could just guess what numbers we could put in here and here so that all of this would make 0, right? What we can do, however, is notice that in this particular quadratic where you have two terms, so notice this is an example where we have two terms, both with x. We've got the x squared term and an x term. So this is one type of question. Okay, for when you have two terms and an x squared and an x, what you want to do is you want to factorize. That's the key thing. You want to factorize the x out because both terms share a common x. So what we do is we take the x out that is common to both terms, and we then ask ourselves, x times what gets us back to each term? So x times x gives us x squared, and x times what equals negative 6x, including the negative, well, x times the negative 6 would give us negative 6x. So you see here that these two expressions are the exact same thing. I've just factorized. Okay, so you factorize here to make life easier. Once we factorize, this helps us a lot because now I don't see any x squareds. Okay, I just see an x, and I see that multiplying. Remember that it is multiplying this bracket here. So there it is x times bracket x minus 6. And what we can now do is we can say that as long as one part of these two things, either the x or the bracket equals 0, the whole thing will equal 0. Because think about it, if the x out the front here was 0, then does it matter what's inside the bracket? For instance, if I make x equal 0, have a look at what happens. It would be 0 equals, we keep our left side 0. On the right side, we would change the x to 0, and you have to change both x's to 0. And what would happen in the bracket is that 0 minus 6 would become negative 6. So we would have 0 times, remember there's a times there, it would be 0 times negative 6. Even though inside the bracket is negative 6, 0 times negative 6 is 0. 0 times anything is 0. So as long as the outside number is 0. So if we make x 0, it doesn't matter what's on that inside of the bracket because it will be multiplied by 0 to then give 0. So now you know that when x by itself goes on the outside of the brackets, one of the answers is going to be x equals 0. Okay, so that's how that works. The other way of looking at it is to look inside the bracket. So now we ignore the x on the outside and we look at the bracket itself. Well, what number could we make x so that the whole bracket was 0? Because then it wouldn't matter what x was on the outside, because if the bracket's 0, it would again be 0 times anything equals 0. And the way to make the bracket equal 0 is to make x the opposite of what's next to it. So what's next to x? Minus 6. What's the opposite of minus 6? Plus 6. So x equals 6, right? There's an invisible plus, of course, is an answer, because think about it. If we made x equals 6, so 6 on the outside because I have an x, then bracket 6 minus 6, what we're going to get there is we're going to get a situation where we have 6 times, well, 6 minus 6 is 0. Therefore, it doesn't matter that a 6 was on the outside because all of it together is going to equal 0. So therefore, we have our two solutions. So that's what you do with this particular type of question. Step 1 was factorize. Step 2 was to establish that if you made x on the outside equals 0, that would be a solution. And then you grab the opposite of what was next to the x inside the bracket, and that will be your other solution. So we now know that our solutions here, we say, therefore, x will equal 0 or 6. So you get two answers. Now here's the interesting thing. What have we actually just found? Well, because we made y equals 0, remember hypothetically, y has become 0 because you want to find the x-intercepts on our graph. Well, let's go back to this graph now. We know that our two solutions was 0 and 6. So therefore, I go and find the relevant spots. Well, here it is. That x is 0. And this x over here on the positive side is clearly going to be the 6. So there we have it. We know that this graph, y equals x squared minus 6x, cuts through the x-axis at 6 and at 0. Now the 0 is typically in the bottom left-hand corner here as an exception, and then we can just write 6 there. We would normally write it underneath, but because of space, I'll just put it there. So you can see that these are the two x-intercepts, okay? And we could find that by doing the method I just showed you, where you need to actually factorize x out and then solve based on making both things, the outside of the bracket equals 0 and the inside equals 0, and you do that separately.